Okay, ladies and gentlemen, nomenclature of epoxide. We did naming of these epoxides this morning, so you'll see a video on that. And we're going to do these 4. And why did he all write an alkene and then the epoxide every time? I think showing you the names will show you why. That first one, trans-2-butene. Trans-2-butene. Trans-2-butene with a new word at the end. Oxide. Oh, that's why. That's why. Sort of like if you're Scottish and your name is McDonald, what does the Mc mean? Son of. Sort of like the Arabic bin, right? It's named after where it came from, right? That's the same thing. It's a good naming system. So all you have to do is imagine the alkene that you used to have before the epoxide happened. Name the alkene and then add what at the end? Oxide means epoxide. So isopropyl cyclooctene becomes isopropyl cyclooctene. Yeah. Uh-oh, should be one word there. And oxide is a separate word. I did not mean for there to be a separation between isopropyl and cyclooctene. I don't know how way to fix that. Make the C extra wide. There you go. There. Okay. Now for the one here, I'm going to show you another system. Okay? This molecule right here is the smallest possible epoxide. You can call it ethylene oxide because it came from ethylene, or you can call it the molecule oxyrane. That's a molecule. You got to learn that name. And oxyrane is a heterocycle. What do you think heterocycle means? I'll tell you one that's not a heterocycle, that's the same size. Cyclopropane is not a heterocycle. And ethylene oxide or oxyrane is a heterocycle. What does the prefix hetero always mean? Different things, yes. Yeah, an atom other than carbon is one of the atoms in the ring. And you know thousands of heterocycles, even if you have a brief inkling of any biological chemistry. All those nitrogenous bases you study for DNA, RNA, ATP, AMP, and all that stuff, they have nitrogen in them, yeah? That's a heteroatom. They're heterocycles. And the number one thing about heterocyclic nomenclature is something that goes against something you learned before. The numbering. In a heterocycle, the heteroatom gets numbered 1. We've never numbered anything except carbon in this course, correct? So you've learned the one exception where you do that, heterocycle. So now I can do this one here. And just remember, with this numbering system, oxyrane covers just the triangle. What are the two groups attached to oxyrane? What's their relative orientation? Sorry? 2 methyl groups. So they're on 2 and 3, right? 2,3-dimethyloxyrane. Oh, it's supposed to be one word. I think I can move that. It's got stereocenters R and S. 2R. Oh, I don't think it's got S. I think it's 3R as well. To do that one, you got to do a double switch. Things get a little sticky. 1, 2, 3. Is that right? No, that's the stereo center. 3. Sorry. And you're like this. 4 switched with 3. 2 switched with 1. That's a 2. 1, 2, 3. It's R. As promised. It's R. I put it in green because we did it in green. Okay, so OxyRain is another system. We had 2 examples with OxyRain this morning, if that went a little fast for you. And don't do OxyRain if there's more than one ring. It's just, you can't make it work. You'd have to name this thing as a group and it's attached twice. Do you know how to do that? I don't know. It's not. So OxyRain is if it's just the one ring, the epoxide ring. Got it? And I think that covers us.